All right, today we're going to talk about the Pythagorean theorem again, kind of connection to last Friday with finding the distance between two separate points. So we're still going to use the formula we talked about on Friday, so the a squared plus b squared equals c squared, but we are going to apply that with coordinate points. So what you're going to do is you're going to plot the given points first. So we're going to do that first. So we're going to take 1, 2, plot that point, and then 5, 5, plot that point. And then what you're going to do is you're going to make that into a triangle so that in step 2 you can use the Pythagorean theorem to find the distance between those 2 points. So we're going to kind of zoom in on this triangle, connect our dots. And because you're using a coordinate plane, you can count your spaces. So you know you have a 3 here, and then you have 4 spaces here, which leaves us missing c. So we can do a squared plus b squared equals c squared. Remember that a and b always have to be the 2 legs on the triangle. So I have 3 squared plus 4 squared equals c squared, because that's our unknown. So 9 plus 16 equals c squared. And then 9 plus 16 is 25. And when we take the square root, I get c equals 5. So the distance between the 2 points is 5. Let's go over to example number 2. So I'm going to plot -6, +6. And I'm going to plot 2, 0. Make those into my right triangle. That should be down straight at the bottom. We'll leave it though. That's 1, 2, 3, 4. Counting this space right here. 6. And counting along this, we have 1, 2, 3, 4, 5, 6, 7, 8. Use a squared, b squared, and c squared to find c, the hypotenuse. So 6 squared plus 8 squared equals c squared. So 36 plus 64 equals c squared. 100 equals c squared. Take the square root. Get c equals 10. So that's how you would do it with finding the distance between 2 points on the coordinate plane. Going to the next section, use the distance formula to find the distance between 2 points. This shouldn't say on the coordinate plane. This should say we're going to actually cross that out. Use the distance formula to find the distance between 2 points, not on the coordinate plane. So we are going to talk about the distance formula. So d equals, this is all going to be under the square root. In parentheses, we have x2 minus x1 squared plus y2 minus y1. You'll notice this is very similar to slope with the x2 and x1. So I would go through and label your points. So we have x1 and y1, and then x2 and y2. And you're going to plug those into the formula to find your distance, being very cautious of your order of operations. So x2 minus x1 is 5 minus 1 squared, plus your y2 minus y1, so 5 minus 2 squared. Work through this with your parentheses being first. So 4 squared plus 3 squared. Keep going with that. So you have 16 plus 9. So the square root of 25 is 5. do this again with your other 2 points, and you can see that from above, those answers match. So you should, when you do this, get 10 in the next one. So distance formula again is distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Plug in your coordinate points. So square root of 2 minus -6. Be very careful with that one because you have the negative. And then 0 minus 6. So this becomes 2 plus 6, which is 8 squared. That becomes 0 minus -6, which is -6 squared. So 16, when you multiply two negatives, you get, oops, not 16, I made a mistake. I always tell you guys not to. 64. Square root of 100 equals 10. So in summarization, how do you find the distance between 2 points? 2 ways to do this. You can use the coordinate plane with a squared plus b squared equals c squared, or you can use the distance formula. D equals the square root of x2 minus x1 squared plus y2 minus 1 squared. And that is it. So after this video, you should be able to use both of these strategies to find the distance between 2 points. You can go ahead and complete your practice using those coordinate planes and the distance formula, and then you will complete your check.